Hi, I'm Jason, and welcome to the Pre-Algebra Tutor. And in this section, we're going to cover division of integers, which is just as important as knowing how to multiply them or add them or subtract them. You have to know how to multiply, and you have to know how to divide in algebra. And so we have our positive and our negative numbers, and so we're going to learn how to divide them in this section. Now, I'm going to tell you this section is pretty easy because we've already learned how to multiply integers. The rules, as you see, are pretty simple. You just look at the signs and you stick a negative or a positive on the sign of the answer, depending on what you had multiplied together. Well, I told you and kind of gave you a preview, and so I'll tell you again here, division of integers really follows the exact same rules as multiplying of integers. So once you know those rules, and you already know them, then dividing integers is very easy because you've already done it before. And so just to recap, when you were doing your division, when you were doing your multiplication, basically, if you had the same sign, like positive times positive or negative times negative, basically you always stuck a positive in the answer. And if you had different signs, then if you had different signs like positive times negative or negative times positive, the answer was always negative. And it's going to be exactly the same for division. In division, if you have the same signs that you're dividing, 4 divided by 2, that's the same sign, or negative 4 divided by negative 2, those are the same sign, the answer is going to be positive, just like in multiplication. If the signs are different, then the sign of your answer is going to be negative, just like in multiplication. So let's go ahead and write that down, but before we get there, we'll do what we did just in the last section, and we'll write down a few different ways that you might see multiplication. The way that you've seen it up until now is something like, 4 divided by 2, okay, is 2. Now you don't see this much, not used much. And the reason it's not used much is just because this symbol is kind of cumbersome. You see, we've been using parentheses and other things and so far, and just to write the symbol down is just kind of messy. So you're not going to see it too much in algebra, but I'm just kind of letting you know that's one way that you can write it, division. Another way you can write division is when you have 6 and divided by 3, you might say that that's equal to 2. This symbol is what you used a lot growing up learning how to divide, and that's fine. That's a division symbol, but you'll almost never see this in algebra. Just because, again, this big symbol gets in the way and all that stuff, and it's just not something you're going to see a lot. What you will see in algebra a lot is basically like a fraction. 10 divided by 2 is written as a fraction. If you remember back, and we're going to cover fractions ourselves here pretty quickly, but if you remember back to your basic fractions, a fraction is basically like a division. This bar here is basically telling you that you're supposed to take 10 and divide it by 2. And so you'll see that a lot in algebra. You'll see large fractions with something on top and something on bottom. That means division. It is also a fraction, but don't forget fractions are just division anyway. That's basically what they are. So this is a different way to write these things. I mean, you might see this occasionally, but you'll see something like this a lot more. So as far as the rules go of how to divide these things, what I'm going to do is write them in a couple of different cases. So let's say case 1, which is sort of the same way we did it last time. Let's say we have the same sign in the numerator and the denominator. Now, don't let these words scare you. Numerator means the top number in your fraction. Denominator means the bottom number in your fraction. So if we have the same sign, then it's going to look something like this. We might have a positive number divided by a positive number. This is always going to give us a positive number. You see, same signs gives us positive number. And if we had something like negative divided by a negative number, then we're still going to get a positive number. These are the same rules as we had for multiplication. So to give you a couple of concrete examples, let's say we had 8 divided by 4. Well, you know that 8 divided by 4 is 2. It's positive divided by positive, same sign, so we're going to get a positive answer. Another example, 6 divided by 1. Right? The same signs are here, so we're going to get a positive 6. Positive 6. Now in this case, let's say we had negative 3 divided by negative 3. We have negative divided by negative, same signs. 3 divided by 3 is 1, and since we have the same sign here, we're going to have a positive answer. right? And let's say we had negative 10 divided by negative 5. 10 divided by 5 gives us 2. And because we have the same signs here, it doesn't matter if they're both negative or both positive, but they're both the same, we're going to have a positive answer. These are the same rules as multiplication. If you have, multiplying two numbers together and they're the same sign, the answer is always positive, no matter if it's positive times positive or negative times negative. We always get a positive. Here, if it's positive divided by positive or negative divided by negative, we always get positive. So we really already know these rules. I'm just writing them down just to make them absolutely clear. So case 2 is the only other case there is if you have different signs. Different signs. What do you do in those cases? Well, I think you can probably guess what's going to happen. So what we're going to have here, as you might guess, is if we had a positive number divided by a negative number, the signs are different there, and it's going to follow the same rules of multiplication. So different signs, I'm going to get a negative answer. And the same sort of thing here. If I had negative divided by a positive number, I'm going to get the same thing. I'll have a negative answer. So anytime the signs are sides are the same, I'm going to get a positive answer. Anytime the signs are different, I'm going to get a negative answer. Same rules as multiplication. So just to give you a couple of concrete examples, let's say you had 15 divided by negative 5. That would be this case. So 15 divided by 5 is 3, but it's going to be a negative 3 because the signs are different. And if you had 20 divided by negative 10, well, 20 divided by 10 is 2, but it's going to be negative 2 because these signs are different. You have positive divided by negative. Same thing down here. If you had negative 9 divided by 3, well, you have 9 divided by 3 gives you 3, but it's going to be negative 3 because the signs are different. And if you had negative 18 divided by 3, then you do the same thing. 18 divided by 3 gives you 6, but it's going to be a negative 6. And that's just simply because the signs are different. So same rules as multiplication. So we're going to go ahead and work a bunch of little problems here to give you some practice in dividing integers. But really, once you know how to multiply them, dividing them is really the same thing. So let's go ahead and work on that now. Let's say we had, just to start off a little bit easier. Now, we don't typically see this written too much in algebra, but I'm going to give you a few problems written like this just because your book is probably going to have some like this. 15 divided by negative 3. Well, the signs are different, so because the signs are different, we're going to have a negative answer. It's going to be negative 5 because 15 divided by 3 is 5, and the answer is negative because the signs are different. What if you had 22 divided by 11? Well, both these are positive, so the answer is positive 2. What if we had 25 divided by negative 5? Well, what we'll do there is divide, so we'll get the answer of 5, but the answer is going to be negative because these signs are different. What if we had negative 27 divided by 9? Negative 27 divided by 9. 27 divided by 9 gives us 3, but it's negative 3 because these signs are different. And just to kind of round it out here, we'll have, what if we had negative 27 divided by negative 9? So same thing. It's going to be 3, but the answer is positive 3 because these signs are the same. So it really does boil down to just looking at the signs of the numbers that you're dividing, just like in multiplication. Let's say you had 30 divided by 15. They're both positive, so the answer is positive. It's going to be 2, because 30 divided by 15 is 2. And if it was negative 30 divided by negative 15, then what you would get is exactly the same answer, positive 2, because both of these signs are the same, so you're always going to get a positive number. Now, if we had negative 30 divided by positive 15, then we would get negative 2 because both of these signs are different. And if we had 30 divided by negative 15, you're going to get exactly the same answer, negative 2, because these signs are different. So I'm just going through a few examples to show you that you're getting the same number in every case. It's just the sign is different because because of this. Now here's an interesting question. What if you had something like 5 divided by 0? 5 divided by 0. You'll see this sometimes. Well, you have 5 oranges and you're dividing by 0 oranges, by no oranges. So really what you'll see a lot in your books, the answer to this that you probably should write down is undefined. And that just means that it's not really a number that you can assign to that, because if you have 5 apples, how can you divide by no apples? I mean, what can you do there? Well, if you think about it, if you have 5 apples and you're trying to divide it up by nothing, you could probably do that an infinite number of times, a whole bunch of times, because if you divide by a very, very small number, then you can divide into it a whole bunch of times. But if you divide by nothing at all, it's really an infinitely large number. So in pre-algebra, you see it written as undefined, and so that's how you should do it, anytime you divide by 0. But really, when you get into more advanced math, you'll find out that that's really equal to infinity, because it's an infinitely large number. You can divide nothing into something an infinite number of times because you're divided by nothing. You can keep on dividing forever and ever because you're dividing by nothing at all. But for now, just go ahead and write undefined, because that's going to be a good answer that you can write down on a test, and everybody will agree that that's fine. So what if you had, next problem, 2 times -3 and then divide by 2. Now, in this case, when you have multiplication and division are on equal footing with one another. Addition and subtraction are also on equal footing with one another. So anytime you have multiplication and division on the same level like this, the same line, then you just kind of go from left to right. You work on it like a sentence. You start here and you go that way. So 2 times -3, signs are different, so it's going to be -6. Still have to divide by 2. And then we say -6 divided by 2 is going to be -3, because these signs are different, so you have to have a negative out there. Okay, now let's say we had 4 divided by -1 times 2. Now again, you don't see this too much in algebra. I'm just giving you these kinds of problems because your book is probably going to test you on understanding these little symbols. Well, here we have division and we have multiplication, so those are on the same level, so we can start at the left and go to the right. So we'll do that. What's 4 divided by -1? That is going to be -4, because these signs are different, so it's negative. You still have to multiply by this 2, so you have to write that out there. And what we're going to have is -8 here, because these signs are different. So 4 times 2 is 8, those signs are different. Now what if we had -16 divided by -4 times -6? Again, you have division and multiplication, so we can start at the left and work towards the right. Now, yes, these are inside parentheses, that's true, and I did tell you to do everything inside the parentheses first, but when you think about it, the only thing in here is just a number. The only thing inside of here is just a number, so you've already there's nothing to really do inside of these parentheses. So we're done with that. Now we just start at the left, since we're doing multiplication and division, and we work left to right, because multiplication and division are really like on the same level. So 16 divided by 4 gives you 4. This is going to be +4 because these two signs are both the same. We still have to multiply by the -6. So 6 times 4 is going to give you 24, but it's going to be -24 because those signs are different. So you see, it really all depends on if the signs are the same or the signs are different. Let's say we have 100 times -10 divided by -5. So we have multiplication, we have division. There's really nothing to do inside of these parentheses here, really, because they're just numbers in there. So we'll just go left to right. So what we'll have is 100 times -10 is -1000, because 10 times 100 is 1000, and these signs are different. So we have a negative sign. And we're going to divide by -5. Now, what we're going to do is we're going to divide by this, and we're going to get an answer of 200, and it's going to be positive because both of these signs are the same. So because they're both the same, we're going to have a positive sign there. Next problem. Let's say we have -12 divided by -2 minus 9. And so here you see what we have is we have division going on, And then we have some subtraction. Now always remember, and we're going to learn about this in another section here as well, but division and multiplication are at a higher level. They're more important, you could kind of think of it, than adding and subtracting. You always do them first, if you can, if you have them in the same line. So here we have division, here we have subtraction. So we're going to work on the division first. All right, 12 divided by 2 gives you 6, and it's a positive 6 because both of these signs are the same. So we're going to subtract 9. Now here's where you go back to do your subtraction of integers. We're starting at 6, and we're going backwards 9. So we're going to go through 0, and we're going to end up at negative 3. And you could think of this, if you really wanted to, as 6 plus a negative 9. That's another way to equally think about it. That's fine. So you're adding integers. So you look at this and you're like, okay, I'm going to subtract them. I'm going to get 3, and the sign of the answer is going to come from the large or absolute value. So that's why you get a negative 3. All right, so let's go ahead and practice our substitution with our variables. So let's say we had A is equal to negative 3, B is equal to 2, C is equal to 4, and let's say D is equal to negative 2. And let's just work on a few of these things. Let's say we had 4A divided by B. 4A divided by B. So we have multiplication going on here, 4 times A divided by B. So these are at the same level, multiplication and division, so we're going to work left to right. First, let's plug in 4 times A, which is negative 3, divided by B, which is 2. And we're going to work on the multiplication first. 4 times 3 is 12. And it's going to be negative 12 because these signs are different. And we're going to divide by 2. So we've done this multiplication. We got the answer. We still have to divide by 2. 12 divided by 2 is 6, and it's going to be a negative 6 because these signs are different. So you're going to get a negative 6 there. Now let's say we have something a little bit different. A times C divided by B. So it's really almost the same thing. You have A times C divided by B, so let's plug in what we have. A is negative 3, C is positive 4, and B is 2. And so we have this multiplication first and then this division, so let's work on that. 3 times 4 is 12, and we're going to have a negative 12 because these signs are different. And we're going to divide by 2. 12 divided by 2 is 6, and these signs are also different. And so we're going to have a negative number right there. So you see, you just plug in and then you work on the rules that you know, so it's nothing magical. So let's say you had negative 2 times A times D divided by C. So let's plug in what we know. We have negative 2 times A, which is negative 3, times D, which is negative 2, divided by C, which is 4. Divided by C, which is 4. And so let's go ahead and work left to right because multiplication, division, they're both kind of equal, so we'll start at the left. We're going to work on these two numbers first. 2 times 3 gives us 6. Positive 6 because these two signs are the same. We still have to multiply by the negative 2. We still have to divide by 4. So let's leave that like that. 6 times 2 gives us 12, but it's going to be a negative 12 because these two signs are different. We still have to divide by the 4. 12 divided by 4 gives us 3, but it's going to be a negative 3 because these signs are different. So you'll get, at the end of the day, a negative 3 for the answer. So you one step at a time. Work on 2 at a time. Never try to multiply these in your head. You'll get it. Eventually, you'll make a mistake if you do that. Let's do one more, kind of a lengthier one. Negative 2 times A times C divided by B plus negative 7. So you see what we have here, multiplication, negative 2 times A times C divided by B, so multiplication and division, and then plus negative 7. And so you have this plus here. This is going to be the very last thing you do because multiplication and division always come first. So let's plug in what we know. Negative 2 times A, which is negative 3, times C, which is 4, divided by B, which is 2, plus negative 7. So let's work on this. 2 times 3 gives us 6. it's going to be positive 6 because these two are the same sign. So then we'll just carry the 4. We haven't done anything with that. We haven't divided by 2, and we haven't added the negative 7. So we're going to carry that down. All we've done is the multiplication. Now, 6 times 4 gives us 24, and it's going to be positive. So we're going to write it down like that. We're going to divide by the 2, and we're going to add the negative 7. Now, 24 divided by 2 gives us 12, positive 12, because these signs are the same. And we still have to add the negative 7. Now, here's where we get to the end of the game here. This is adding two integers. You're adding two different signs, so what you're going to end up doing is subtracting them. And 12 minus 7 is 5. And the sign comes from the larger absolute value, so it's going to be a positive 5. So that's the answer there. So we are done with this section. We have learned how to divide integers. Congratulations, you're really far along in your pre-algebra studies. Multiplying and dividing and adding and subtracting integers are some of the core topics in pre-algebra and algebra and on beyond that in every math class that you'll ever take. So please make sure that you understand really, really well how to multiply and divide and add, subtract these things. Multiplication and division, you can see, really are following exactly the same method. You're looking at the sign of what you're dividing or multiplying by and putting a sign on the answer, because of that. And so that's really the end of the story there. Multiplication and division follow the exact same rules. So I'm Jason, practice your problems, and I promise you that you do really well, and you'll go on and you'll get confidence in this, and then that's going to help you when you solve equations. It's going to help you when you do all the things that we do beyond this. If you can get comfortable with adding and subtracting and multiplying and dividing these integers, I promise you that nothing else in the future is going to give you any problems.